Welcome to this quick guide on computer hardware basics. Whether you're a beginner or just need a refresher, in the next 10 minutes, you'll learn the key components inside a PC, how they work, and even how to assemble one yourself. Let's dive in. Every computer is made up of essential hardware components. Here's what you'll find inside a PC. Central processing unit, the brain of the computer. It does all the calculations. RAM, memory, temporary storage for running programs. More RAM means better multitasking. Storage, long-term data storage, either a hard disk drive HDD or solid-state drive SSD. An HDD is slower and cheaper but stores more data at a lower cost per gigabyte. An SSD is much faster and more durable, but also more expensive. The motherboard, the main circuit board connecting all components via ports and slots. Power supply unit supplies power to everything. There are different types of computers like desktops, laptops, servers, embedded systems, etc. A desktop computer is the most common type. They're powerful and offer high customizability at a reasonable price. Laptops are portable, but not as powerful. They're convenient, but upgrading or repairing them is harder. Servers are high-performance machines that sit inside a network. They store and distribute data over a network to clients. And finally, embedded systems are specialized computer hardware built into a device like an ATM, mobile phone, smart TV, robotic vacuum cleaner, etc. These perform dedicated functions in specific environments. Now let's see how these parts come together. Here's a quick step-by-step PC assembly. Turn off power and ground yourself. Open the case and grab the motherboard. Carefully align the CPU pins. Gently place and lower the CPU. Don't force or bend anything. Secure the cooler. Add RAM into the slots. Click it in firmly. It should snap into place. Mount the motherboard inside the case using standoffs. Connect the power supply unit PSU to the motherboard with the included cables. Make sure everything is secure. Install storage, either an HDD or SSD, and attach the power and data cable. Also, add a GPU if needed for gaming or graphics work, and finally, close up the case. Don't forget to plug in the monitor, keyboard, and mouse, power on, and check that everything works. If your PC won't start, don't panic. Check all the connections, reseated RAM, or test the PSU. Now that we have our computer assembled, let's talk about peripherals, which are external devices connected to a computer, like a keyboard and mouse. They make the computer usable for humans. Storage is also a type of peripheral. There are two main types of storage, HDD and SSD. We already talked about the differences between them. Peripherals can greatly enhance a computer's capabilities. Here are a few examples. A USB drive allows users to easily transfer data between computers and backup files. An optical drive is used to read and write data from C discs, DV discs, and Blu-ray discs. Although they're becoming rarer, they are still used for software installations and backups. Printers and scanners allow users to generate hard copy documents and images. Let's now get inside the computer and explore the internals. Let's start with the central processing unit, the brain of the operation. The CPU performs calculations and runs programs. It has three main parts: the control unit, the arithmetic logic unit, and the scheduler. The control unit fetches and decodes instructions. The ALU performs calculations and comparisons. And the scheduler manages and allocates resources to the other two units. Today, CPUs come in various forms, including Intel and AMD processors for desktops and laptops, Apple Silicon for Mac computers, and Qualcomm Snapdragon SoCs for mobile devices like smartphones and tablets. They are all designed to run machine code, the language understood by computers. Machine code consists of binary digits, bits, either 0 or 1, which control the CPU's behavior. Modern CPUs are incredibly complex, containing billions of transistors on a single chip called an integrated circuit. This complexity allows them to handle multiple tasks simultaneously through parallel processing. As technology advances, CPUs continue to become smaller, faster, and more efficient. Next, let's look at the random access memory, or RAM. It's like a workspace for the CPU. RAM stores data and instructions that the CPU needs to access quickly. Without RAM, The CPU would have to read every instruction from the storage drive each time it needed to execute it, making it much slower. RAM is volatile, meaning it loses its data when the power is turned off. To avoid losing unsaved work, always remember to save your progress regularly. RAM typically comes in the form of modules installed on the motherboard and is measured in gigabytes gigabyte or terabytes TB. More RAM allows the system to run more programs at once and switch between them more quickly. However, having too many programs open can slow down performance. Additionally, RAM is subject to wear over time and can cause data loss or system crash if it fails, moving on to input and output devices. These are peripherals that allow users to interact with the computer. An input device takes user input and sends it to the CPU for processing. Some examples include keyboards and mice. An output device receives process data from the CPU and presents it to the user in a usable format. Examples include monitors and speakers. There are also devices that both input and output data, such as a smartphone screen, which can take user inputs like taps and swipes and display outputs like videos and games. Finally, let's discuss firmware, a type of software that resides on non-volatile memory chips on the motherboard. It enables essential functions without needing an operating system like booting up the computer. BIOS or Basic Input-Output System firmware is an older standard used by most PCs today. Newer UEFI or Unified Extensible Firmware Interface is gaining popularity. Firmware can be configured to customize the computer's behavior before it boots into the operating system. Some examples include changing the boot order, monitoring hardware tone and voltages, and enabling or disabling components like Wi-Fi or USB ports. Updating the firmware can sometimes improve stability, but it is essential to do this cautiously as it can lead to serious issues or even break the system if done incorrectly. Now we understand the major hardware components and their functions, let's put it all together. When you turn on a computer, the firmware, specifically the BIOS, starts up first. It checks all the hardware components to ensure they're working correctly. Then it loads the operating system into the RAM. The OS uses the hardware to interact with the user through the input and output devices. Users can then use software applications that utilize the hardware to perform various tasks. For example, a web browser uses the CPU, RAM, GPU, and storage to display and interact with websites. Want to learn more about hardware? Check out our full course on hardware and networking. Link in the description below. Thanks for watching. Like and subscribe for more tech tutorials. And don't forget to check out our full courses on our website. You can find courses on everything from cybersecurity to cloud computing. See you in the next video. Thanks for watching. Like and subscribe for more tech tutorials. And don't forget to check out our full courses on our website. You can find courses on everything from cybersecurity to cloud computing. See you in the next video.